Dear students, I am Santan, working as a physics faculty in Target English Medium School. One small request, what is that one means? If any student is not subscribed our school channel, first you can subscribe and tap on the bell icon. If any videos are uploaded by our management, immediately the notification will be displayed on your screen. That's why everyone must be subscribed our school YouTube channel. Now today in this part video from the chapter of friction, I would like to teach what is the relation between frictional force and normal force. Means how the frictional force is depend on the normal force. So actually in our previous video we clearly discussing about what are the factors affect the friction. So mainly three factors are affect the friction. First one is nature of the surface of material or roughness of the material. Second one normal force. Third one area of contact. How these three factors will be affected the friction, that is we are discussing. But in our previous video we clearly discussing about the relation between frictional force and roughness. So and finally after completion of that topic or experiment or activity, so you clearly understand or conclude that roughness of the surface is increases, frictional force is also increases. Roughness of the surface is decreases, frictional force is also decreases. In case of nature of the material, frictional force is depend upon the nature of the surface of the material, because of when you are using the 3 or 4 different surface of the material, for every case the frictional force offered by the body is not same. Is nothing but the distance covered by the body on that particular surfaces is not same. That's why we can say that every surface will be offered its own opposite force on the motion of a body, is nothing but frictional force. Now in this time we discuss that frictional force and normal force. So this is our main topic. Means during the examination, in what type of way they are asking the question, means explain how to verify frictional force is depend on the normal force. That is they are asking that. Okay. So for proving of how the frictional force is depend upon the normal force, we discussed with the help of one activity. So it is a table. It is a brick. All of you listen very carefully. If we can perform or conduct the experiment, which experiment? The relation between frictional force and normal force, or how the frictional force is depend upon the normal force. That is one. In this one, we want some materials. Means which materials are required to us to conduct this experiment? Means table, two identical bricks. Identical is nothing but the two bricks which will have same size, mass and shape. Everything is okay. That's right. Now we can take the two identical bricks, a spring balance, tiny rope. These are the materials are required to us. So what is the first one? Okay, two identical bricks. Two identical bricks. Second one, a large table. It is made up of either wood or iron. Next, spring balance. Next one is a tiny rope or thread. So these are the materials are required to us to perform or conduct this activity. First of all, we can take one brick. That brick is placed on the horizontal surface of a table at one corner. Now that brick is tied with a rope. A small, narrow area of the cross section of the rope we can take, and the brick is tied with the rope. Generally, it is the brick we can say that the brick is tied with the rope in horizontal and vertical mode, both sides. And further, the rope is connected to one end of the spring balance. So this is the spring balance. So what is the use of the spring balance? Means by using the spring balance we measure weight of a body. Listen very carefully. So generally we know the two physical quantities symbolizes that mass and weight. But most of the students don't have any idea the distinguish between mass and weight. They are consider these both are same, but mass and weight both are not same. They have so much difference is there. Mass is nothing but the amount or quantity of matter present in a body, or the amount of the quantity of matter contained in a body is called mass. But weight is nothing but the earth attractional force or earth gravitational force is acting on a mass of a body. So that's why both have so much difference is there. So anyway, laterally we discuss about that concept. Just we can come to that one. The mass of the any body we are find easily by using a physical balance or common balance. But we can find weight of a body by using which one? Spring balance. That's right. Now here we are using which one? Spring balance. On the spring balance outer surface, means on outer surface, they are already graduated the readings in grams or Newton. Mostly I mentioned here which one? Newton's. Spring balance we have taken here. So in this one it is the 0 Newton. So we taken 100 Newton capacity of the spring balance. Like this one I have mentioned that. So here one needle is there. This needle is connected to the a pointer metallic pointer is there. This pointer will be connected to the lower end of the spring balance by a spring. This lower end of the spring balance we connected to which one? Tiny rope, which is already tied to which one? Brick. So once again listen very carefully. First of all, we can take a brick. The brick is placed horizontally. Here the brick will have the two portions. It is the horizontal, it is the vertical. That's why first of all we can take a brick. The brick is placed on the surface of the table horizontally. Now we can take a tiny rope. The rope will be tied to the brick and this rope connected to a spring balance of one end. What is the use of the spring balance? With help of the spring balance, we find what is the weight of a body. Weight is measured in newtons. And on the upper surface of the spring balance, they are already graduated the readings in the Newton and grams. But we take in which type of spring balance? Newton. The spring balance which is already graduated the Newton values means weight values, that is we are taken here. Now initially, before we pull the brick with help of the spring balance or through the spring balance, at that time you are observing that the pointer needle on the spring balance is showing which one? 0. Now the hook of the spring balance will be held with help of your finger and slowly try to pull the brick. So you are observing that. So don't apply the large force at a time. So you apply the force with help of the fingers on this one through the spring balance. You are applying the force slowly. Means slowly try to pull the brick through the spring balance with help of your finger or hand. And you are observing that. So the needle will be gradually moves to so 10, 20 like that one. So when the brick is ready to set into the motion, or when the brick is set into the motion, at that time you are observing that the reading means which reading was shown in the spring balance. For example, just for understanding of you, it is showing which one? 50 Newton. Means when you are applying the force on the brick through the spring balance, at that time in the spring balance when the reading is showing 50 Newton, at that time the brick is set into the motion. But so at 10, 20, 30, 40 up to 50, so you apply the force on the brick, but the brick still it is in which position? Rest position. Why the brick is in the rest position even though you are applying the force? First you are applying how much force? Gradually increases. Just you can consider the main only. 10 Newton is applied. This force means some force is acting in this direction. That is which force? We know that already. Frictional force. How much is acting? 10 Newton. Here 20. Brick is not set into the motion. It is still rest. Means opposite force is also 20. Here 30. This side is also 30. 40. Here also 40. Where you can apply the 50, the body set into the motion means. So the frictional force offered by this brick is what is that one? 50 Newton. That is the answer that according to them. But that is not our concept mainly. Our concept is what is that one? Relation between frictional force and normal force. That's why we can say that. So here the brick is placed on the surface of the table. On the brick, what will be acting? You know that. Here gravitational force is acting vertically downward. When a body is placed on the surface of the table or a body is placed on the surface of the earth, if a person is standing on the earth, every body on the surface of the earth is attracted by the earth gravity in vertically downward. That's why the brick which is placed on the surface of the table is attracted by the gravitational force vertically downward. But at the same time, the brick does not go towards the gravitational force. Still, it is in the state of rest. It is in state of rest on the table. Means for the opposite of the gravitational force on the brick, the surface of the table will be offered some force, that is the normal force. That is normal force. Now here we are considered that two identical bricks means each brick mass is 1 kg. We can say that. What is the mass of each brick? 1 kg. That's why when you are taking 1 kg mass of a brick, and in 1 kg mass of a brick, how much force you are applied to set into the motion? 50 Newton. So mass of a body and normal force, it is in kilograms, it is in meters, whatever the figure. So here you are observing that. So normal force directly we cannot observe in that, but the normal force you are observing in the way of frictional force. But anyway, here frictional force we can say that 1 kilogram is here. Here how much one? 50 Newton. Next in the second case. Now we can take another second brick. The second brick is placed over on the first brick. Means so two bricks will be placed one upon the each other, one upon the another one. Means like this. Like this one. So totally, so what, which type of bricks you are taken? Two identical bricks. So that's why the first brick mass is 1 kg, means the another one is also 1 kg. Totally, how many kgs we placed on the, okay, this one 2 kgs. Are understanding or not? So here I will be saying one value here, one thing. Mass of a body in kilogram. Next one, normal force. Next one, frictional force. We can set the three concepts here. So first of all, listen very carefully. Okay, once again I will explain. First of all, we can take a brick. It is placed horizontally on the surface of the table. Now we can take a rope, tiny rope. The rope will be tied to the spring, tied to the brick, and further the rope is connected to a spring balance. The spring balance is useful to measure the weight of a body. Initially, in the spring balance, the reading is showing the 0 Newton when before you apply the any force on the brick. Now, another end of the spring balance will be hold with the help of your finger or hand and slowly try to apply the force, okay, on the brick up to it is set into the motion. When the brick is set into the motion, at that time, what is the reading shown in the spring balance, that is you are noted. That reading is represented the frictional force offered by the surface of the table on the brick. That's why here we are observing that what is the mass of the body? 1 kg. What is the frictional force? According to that one, 50 Newton. It is not a practical values, just okay, imaginary, assumed values only. At the same time, what is the normal force is acting on that one? So we know that when you can hold, means so this is the brick. This brick mass is 1 kg. When you can hold 1 kg mass of the brick with help of your hand or palm, okay, how much force is acting in downward? 9.8 Newton force is acted by which one? Gravitational force. When initially we have taken only one brick, okay, that's why one brick mass is how much one? 1 kg. On the 1 kg mass of the brick, how much gravitational force is acting? 9.8 Newton. That is approximately equals to 10 Newton. So, but 10 Newton force is acting on the brick in vertically downward, but the brick does not set into the downward, it does not come to downward, still it is in the state of rest on the table, means some force is acting vertically upward by the table on the brick. What is that one? This magnitude always equals to this one. You know that already according to net force. When the two forces are equal in magnitude but in opposite direction, the body is in which position? Rest position. That's why normal force is also on the single brick. How much one? 10 Newton. You have considered that. 10 Newton. It is also Newton. Frictional force is also Newton. We have considered. Next, now we take another brick of the same mass. It is placed over the first brick. And again, we can repeat the same experiment. In the second case, you are observing that you are applying the 100 Newton force. 2 kg is there, 100 Newton. At that time, so here we are observing that when you can increase the mass, then what will be happen? First you are observing that. When you are increase the mass, in this second case, how much kgs are there? Each brick is 1 kg, means how many bricks you place here? 2 bricks. That's why 2 bricks means on the each brick, how much force is acting vertically downward? 10 Newton. That's why 2 bricks means 20 Newton in downward, 20 Newton in upward in case of 2 bricks. That's why, so here 20 Newton or 20 normal force. But with help of the spring balance, how much force you are applied on the 2 bricks to set into the motion? 100 Newton. That's why on the brick, how much force is offered by the frictional force? 100 Newton. Now let me come. Okay, 1 second I will explain this one. After that, so I will prove practically this one. First of all, we can take one brick. It is placed horizontally on the surface of the table at one corner. Now we can take a tiny rope. It is tied to the brick and further it is connected to the one end of the spring balance. Next, third point. Now another end of the spring balance or hook of the spring balance will be hold in your fingers, and so you can try to pull the brick, gradually increasing the force until the brick set into the motion. Next, fourth part. When the brick is set into the motion, at that time the spring balance will be showing what is the reading. That reading is you are noted. So the reading is represented which one? Frictional force. Why? Because of means on the brick we apply the applied force horizontally. In horizontally, normal force is not acting. Normal force is acting always in vertical mode. It is balancing the gravitational force only. In the fourth chapter I clearly explained. That's why here on the brick, so our applied force through the spring balance is acting this direction. In the opposite direction, which force is acting? Frictional force. In case of a single brick, 50 Newton force is applied on the brick through with help of our hand through the spring balance. At that time it is set into the motion, means what is the frictional force offered by the brick? 50 Newton. So in how much mass? 1 kg. These values are not exact values. Listen very carefully. These are the assumed values only. That's why in case of 1 kg mass, how much frictional force? 50. At the same way, we consider the normal force because of our concept is related between frictional force and the normal force. That's why on 1 kg mass of a brick, 9.8 Newton gravitational force is acting vertically downward. That is found by the Newton scientist. Here you can take how much mass? 1 kilogram of the brick for our assumed purpose only. That's why what is the normal force is acting on the brick? 10. Okay, normal force is 10 and frictional force is 50. Next, one more same. Okay, mass of the brick you can place on the other one. So total here mass is increases or not? If the mass is increases, automatically weight is also increases. That's why how much normal force is acting on the two bodies? 20 Newton. Because of 20 Newton gravitational force is acting on the 2 kg mass of a body vertically downward. So mass of the body is 2 kg and normal force is 20. At that time again you can repeat the same experiment. You are observing that when the reading on the spring balance is showing the 50 Newton. At that time the bricks are not set into the motion. When the reading comes to the 100 Newton, at that time they set into the motion. That's why. So what is the frictional force offered by the two bodies? In the second time 100 Newton. Now you are observing mainly here these two columns only. Normal force is 10, frictional force is 50. Normal force is 20, frictional force is 100. So means if normal force is increases, frictional force is also increases. If normal force is decreases, frictional force is also decreases. That's why what it says that here frictional force is depend on the which one? Normal force. If normal force is increased, frictional force is also increased. Normal force is decreased, frictional force is also decreased. This is our experiment. Okay, most probably in the coming videos, practically I will give a demonstration about this topic. Thank you.